Last lecture we have seen interpretation of P is equal to 0 when P x1 y1 does not belong to S. It is chord of contact. We have derived that equation. And maybe the lecture before that, this is chord of contact. And before that, what we had proved is T is equal to 0 when Px1 y1 belongs to S tangent. Okay, and maybe tangent is a special case of chord of contact. So this was our 1 and this was our 2. Now there are a couple of more interpretations to T is equal to 0, and that makes it very important equation as far as any conic section is concerned. Definition. Let S is equal to 0 be a conic section. Let P x1 y1 or P1 x1 y1 be any point in the plane of S. Now I am putting it in the plane of S right now because we are discussing two-dimensional geometry, planar geometry. Okay, maybe there could be some interpretation if this happens in three-dimensional space or more than three-dimensional space. We will figure out how this is going to change, or will it remain same, etc. later on. But before that, we need to learn two-dimensional geometry in detail, which we are doing now. So P belongs to the plane of S. Then what should we do? Then let P1 does not belong to S. Let L be variable life. Passing through P1. Let L intersect S at A and B. Okay. Let T1 and T2 be tangents at A and B respectively to S. Let Q be intersection of T1 and T2. Then, not then, it is not, it is definition. So, locus of Q is called polar. Of pole P. Okay, that is what is the definition. Let me explain you. Some conic is there. There is some point in the plane and there is a variable line. So I am putting two positions of the line. Okay. Then there exists, this is A, this is B, A, let us call this P1. This is S, then this is A, this is B. What we do is we draw tangent at this point, we draw tangent at this point. Maybe this is first Q1. If you do it some other point, Q2. And as this line L is a variable line, it will keep on producing Q1, Q2, Q3, Q4. Locus of Q is polar. And P1 is called polar. So locus of Q is a polar of the point which is fixed. Point P is not moving anywhere. P1 is fixed in our case. And therefore, that is what is definition. Okay. So, समजलंय का सगळ्यांना? Okay, so the question now is, let S be the general degree 2 equation, degree 2 curve, and point P1 is x1, y1. So find the equation of polar. That means find the equation of locus of Q. Okay, now whenever you are solving a locus problem, you should solve it in the locus way. There is no reason why you should not use our standard method of solving locus problem. Now therefore, let solution, let Q be h comma k, or if we are not happy with h comma k, we can say let Q be x dash comma y dash. Let Q be x dash comma y dash. Okay, one of the intersection is x dash comma y dash. Then the geometric condition, if Q is x dash comma y dash, this implies AB, line AB is chord of contact. Chord of contact with respect to S, yes or no, and we know the equation of chord of contact. Therefore, the AB, the variable line AB will have equation looking like AX x1 plus B, no, not x1, sorry, AX x dash plus BY y dash plus H x y dash plus y x dash. Correct? Plus G times x plus F times y plus y dash plus C is equal to 0. This is equation of line AB. P1 x1 y1 belongs to AB because that is the variable line through P1. Therefore, A x1 x dash plus B y1 y dash plus H into x1 y dash plus y1 x dash plus g into x1 plus x dash plus f into y1 plus y dash plus c is equal to 0. This statement is true because x1 and y1 satisfy this equation. That is what is the algebra that we can do. And our q is a variable point. Therefore, replacing x dash by x and y dash by y, we get equation of desired locus, which is ax1 plus byy1 plus h into x y1 plus yx1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0, which is t is equal to 0. So t is equal to 0 is a polar of point P. Understood? It is actually the same thing doing otherwise, exactly opposite way. Maybe check whether you have. Why we are doing all these proofs? That because your ability of dealing with these situations is getting improved. You can visualize the problems in much better way if you are doing this kind of work. And we were studying circle, but suddenly we started studying general degree 2 equation in x and y, which is general conic section, because these are the things which we will do for every conic section. When we learn ellipse, we will do what is chord of contact of ellipse, what is polar of ellipse. We will do these four things. T is equal to 0. It will have four interpretations, and all conic section will behave exactly the same. Okay. So these are the three. T is equal to 0. If point is on the curve, it's a tangent. If point is not on the curve, it's a chord of contact. If point is pole, then T is equal to 0 is a polar. That means whatever locus that we have defined right now. If you draw any variable line passing through P, it intersects the curve at 2 points. Draw tangents at those 2 points, then the intersection of tangent is going to be straight line. Yet another important thing, here I have mentioned locus of Q, but locus of Q happens to be straight line. And therefore we are calling that locus as a polar of the fixed point pole. Okay, so there is a fourth interpretation. Let us do it.
Excuse me, sir. Sir, what is the difference between the polar of a pole and the chord of contact?
Very good question. For all practical purposes, it is one and the same. However, polar is constructed by a variable line, intersection, drawing tangents, and getting the line. So far we got the equation same. We were not aware that polar is the chord of contact. But now having learned the equation, it is same in conic sections at least. In conic sections, polar is same as pole. T is equal to 0. Very good question. Okay. Now next. Do we know this terminology? Harmonic conjugates. I think we are aware of that. A and B, points A and B are said to be harmonic conjugates of P and Q if and only if one A comma B comma P comma Q are collinear and what is second condition? PA upon AQ to opposite of PB upon BQ. Numerically they are same, but sign wise they are opposite. So they are called harmonic conjugates. So geometrically, if I have a line P, Q, then this is A, 1:2, और थोड़ा दूर घेऊया त्याला. This is A, then this is B. So PA upon AQ is equal to PB upon BQ. Do you understand this? That is why with minus sign is because external division, plus sign is because internal division. So A comma B comma P comma Q must be collinear, because if they are somewhere in the plane, we will not be able to deal with them, and therefore they will not be called harmonic conjugates. Points A and B are said to be harmonic conjugates of P and Q if and only if this happens. Now, corollary is numerically they are same, therefore let me just work it out. PA upon PB is equal to opposite of AQ upon BQ. But if I want to numerically, I am keeping them ratio, so I write it like this: AP upon PB is equal to minus Q minus AQ upon QB. Right? So if this is true, then this is also true, and therefore corollary is points P and Q are harmonic conjugates of A and B. समझते हैं? So AP upon PB is equal to opposite of AQ upon QB. So there is a duality. So this is what is the definition of harmonic conjugates. Now, how this fellow is going to be useful to us now? Suppose we have got a conic. आता हे नीट लक्ष देऊन ऐकलं तर सगळ्यांना समजणार आहे. If you pay proper attention throughout the discussion, then you will understand. Otherwise, if you are lost in between, then you will not understand what is happening in the end. Okay. So now, very important. I have a conic section and I have a line. Let this line be point be P. Now this is going to be a variable line through P, same as in case of polar. So I am just showing you the one position of this particular A, B. It intersects the conic at A and B. Now, understand this. If I choose any point here, Q, then I can always say that PA upon AQ is going to be some ratio, and PB upon BQ is going to be some other ratio. PB upon BQ is going to be some other ratio. So Q can be anywhere on this line. And if you have Q anywhere in this on this line, there will be one ratio K1 PA upon AQ, and there will be another ratio PB upon BQ. But suppose K1 is equal to K2, if K1 is equal to K2, or maybe if K1, absolute value of K1 is equal to absolute value of K2, and they are opposite in sign, or maybe it's making it so complicated, if K1 is equal to opposite of K2, then Q is what? Then P and Q are harmonic conjugates of A and B. Okay, बरोबर है का? Then P and Q are harmonic conjugates of A and B, or A and B are harmonic conjugates of P and Q by this above discussion. But else this Q can be anywhere. If K1 is not equal to K2, Q can be anywhere on that line, and you will end up getting one ratio equal to PA upon AQ and another ratio as PB upon BQ. Now if Q is over here, then both of them will be negative because it is external division. Both the ratios will be positive, PA upon AQ and PB upon BQ. Both of them will be positive. If Q is here, then PA upon AQ and PB upon BQ, both of them will be negatively signed. If Q is between A and B, one is positive, one is negative, and so on. Q can move anywhere on that line. Okay, that is one part of the story. So the fourth representation of T is equal to 0, that is the answer that I am trying to tell you. Locus of harmonic conjugate Q along with P of the points of intersection A and B with respect to S is equal to 0 is T is equal to 0. That is what is the fourth interpretation. If you see that if you every time get the correct position of Q here, this is harmonic conjugate of A and B along with P. P and Q are harmonic conjugates of A and B. That is the position. It is going to be a unique position on this line. Now, if you have another position, another line passing through P, then you will end up getting, I mean, this is going to be A, this is going to be B, this is P, and there will be a unique position of Q on this line also. If on this line also Q can vary anywhere. But if you want harmonic conjugate, then there is a unique position of Q here. And then if you collect all the unique positions of harmonic conjugate of Q along with P with respect to A and B, then you will find that it is a straight line. and that straight line is the same as that of chord of contact, that of polar of P. That is what is this. Now I give you some time because it is not easy to prove this because there are a lot of complications you will have to deal with. However, who knows, somebody of you may come up with easy solution. Therefore, I wait for some time, try to do it. If you have not understood the statement of the problem, you ask me again. Basically, we are trying to find out the locus of harmonic conjugate Q along with P with respect to the points of intersection A and B, and we claim that locus of Q is a straight line and it is the equation T is equal to 0. Okay, this proof or solution is going to be very important because of many different things which we will try to understand. Okay, so this is the correct setup. Now let this P be x1 comma y1. Let Q okay, let me make a new diagram because I have spoiled that diagram. This is my conic, this is my P, this is point A, this is point B, and suppose there is a point Q here. And instead of x dash y dash, let us keep x2 y2. Let coordinates of Q be x2 y2. Okay. Now we are not using that harmonic conjugacy at the moment. Therefore, PA upon AQ, suppose if PA upon AQ is equal to K, right? Then I can always visualize this A as B because this B point is also a point of intersection of this conic. So, okay, this A is a representative point. Anyway, this line is a variable line. So, any representative point will possess K ratio with such that PA upon AQ is equal to K. So, PA upon AQ in this case, suppose 3:2 if I see it correctly here. And maybe here it is 2:1, PB upon BQ. Okay. So A is a variable point. Therefore, if PA upon AQ is K, then I can always write coordinates of K, coordinates of A as PA upon AQ is K as to 1. So coordinates of A will be kx2 plus x1 upon k plus 1, comma ky2 plus y1 upon k plus 1 using section formula, right? And now this point A belongs to S. Therefore, what we will get? As A belongs, let me write it here. A belongs to S implies, what does A belong to S imply? 58%. A belongs to S imply that A will satisfy the equation of S is equal to 0. And that is A kx2 plus x1 upon k plus 1, that is x1 x kx square plus b ky2 plus y1 upon k plus 1 square plus 2h kx2 plus x1 upon k plus 1 into ky2 plus y1 upon k plus 1 plus 2g into kx2 plus x1 upon k plus 1 plus 2f ky2 plus y1 upon k plus 1 plus c is equal to 0. So the point A satisfies S. And now it is algebra that we need to deal with. The best way is to multiply every term by k plus 1 bracket square, right? So shall I do it in one step? Let us do it in one step, or maybe let me write down a into k plus 1 bracket square will vanish here, so I get kx2 plus x1 bracket square plus b into ky2 y1 bracket square plus 2h into kx2 plus x1 into ky2 plus y1 plus 2g k plus 1 kx2 plus x1 plus 2f k plus 1 ky2 plus y1 plus k plus 1 bracket square is equal to 0. Be with me. I think this step is correct and everybody should understand. Now let us jump. We know that there will be k square terms, k terms and constant terms. So let us collect what is the coefficient of k square. A x2 square, b y2 square.
So it should be C into K plus 1.
Yes, sir.
Here last, yes. Here it should be c into plus c into k plus 1 square. Okay, good. So k square ax2 square by2 square, what will be the term here? 2h x2y2, correct, plus 2g x2 plus 2f y2 plus c. That is the coefficient of k square. Plus, what is the coefficient of 2k? 2k ax1 x2, correct, plus by1 y2 plus 2k h आणि इथे 2k कॉमन आला h x2
Y1.
y1 plus h into x2 y1 plus y2 x1, correct? Yes or no?
Yes, sir.
Yes.
Plus what should I take out now? Okay, this is what I am doing for 2k. This is small bracket. As far as g is concerned, 2k into g times plus x2 plus f times y1 plus y2, and what is 2k into c. That is the bracket complete. This is the coefficient of 2k. Sanika Joshi. And then what is the constant that is remaining? Constant term here is ax1 square plus bx1 square plus 2h x1 y1 plus 2g x1 plus 2f y1 plus c is equal to 0. Okay, instead of writing it in such a long fashion, we can write it as, oh, this is our S is equal to 0, but x2 y2. Now, see, this bracket is not going to be 0 because not on the Q is not on the circle S. Okay. So as a special case, what will happen we will discuss later. But in general, the Q and P are not on S. So I can call this as S2. If I put second point in the equation of S, I get S2 K square plus 2K times S12. Is that okay? And then the last term is S1. This is S1. Put this point in the equation is equal to 0. Very good. Now, are we done? This is, okay, the name of this equation is JOACHIMSTHAL, Joachimthal's ratio equation. This is Joachimsthal ratio equation. That is the only time we will pronounce it like this. Otherwise, we will call it as JR equation. Okay? So JR equation, we will use it one more time in our life, but presently it is time to use S2K square. So what is this K? Suppose we solve this, and this is a quadratic equation in K, and if we solve it, we will get two values of K. Oh, that is correct. We wanted two values of K. K is the ratio in which A divides PQ. So if Q is well behaved, if Q is anywhere on this variable line, then PA upon AQ will be K1 and PB upon BQ will be K2. So those are the of this equation, K1 and K2, if Q is moving on the line, variable line. However, now we are interested in a situation where Q is such that is equal in, it gives K equal in magnitude but opposite in sign. So K, these are the roots, K1 and K2 are the roots of this equation, and we want K1 to be opposite of K2. That means sum of the roots should be equal to 0. Very good. If sum of the roots equal to 0 implies S12 is equal to 0. Right? Therefore, what is our S12? S12, this implies x1 x2 plus by1 y2 plus h into x2 y1 plus x1 y2 plus g into x1 plus x2 plus f into I1 plus y2 plus c is equal to 0. That is what is the spatial position of Q, which is going to be harmonic conjugate of A and B along with P. See, that is the spatial position of Q we are talking about. When K1 equals opposite of K2, that is the position of Q on the line. It is unique harmonic conjugate position. That is why we are equating sum of the roots equal to 0. We get this equation. And now we were searching for locus of Q. And we assumed coordinates of Q as x2, y2. Therefore, replacing x2 by x and y2 by y, we get desired equation of locus. Replacing x2 by x and y2 by y, we get desired equation of locus, which is axx1 plus byy1 plus h into xy1 plus yx1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. So this is P is equal to 0. It is a locus of harmonic conjugate. I wait for some time, I make it on one board, check whether every step is understood or not, and any questions we will figure out. Okay, so the question is why the sum of the roots equal to 0? Let us explain it again. Now I have a segment. This is A. No, let us keep it P. I have a segment. This is P. This is A. This is B. And there is a Q somewhere on this line. Okay. What should I do? Let us skip. Let P be at 0. Then my A is at 3. 4, 5, 6, 7, 8, 9. B is at 9. Okay. So suppose I put Q here now at this place, Q1. Then PQ1 upon Q1A is how much? 2 upon 1. Correct? And P Q1, sorry, wrong. P and Q are supposed to be harmonic conjugate. So PQ1 upon PA upon AQ1 is how much? 3 upon 1. Correct? And PB upon BQ1 is how much? 9 upon 7 minus, because this is external. PA upon AQ, this is also external. PA upon AQ. Correct? Have you understood this? So this I am calling as K1, this I am calling as K2. Case 1. If I change the position of Q now and say put over here, this is Q2. Suppose this is Q2. Then PA upon AQ2 is equal to 3 upon 2 and PB upon BQ2 PB 9 upon 1, 2, 3, 4 9 by 4 with negative sign. I will call this as K1, this as K2. Yes or no? So this is one ratio, this is another ratio. Then suppose we say Q3 is say here. Then how much is PA upon AQ3? PA is 3, 1, 2, 3, 4, 3 by 4. That is my K1, internal division. And PB upon BQ3, PB is 9, BQ3 is 2, it is 9 by 2 equal to 2 minus. Now every time you observe in all these three examples that K1 is not equal to K2, K1 is not equal to K2, K1 is not equal to K2. But then can we really find out a position of Q where K1 will be equal to Q2? Can we really find out the position of Q such that K1 is equal to K2? Can we? I think we should be able to find out in this number line, on this number line. Can somebody tell me what is the position of say Q4 where K1 becomes numerically equal to K2 but opposite in sign? Can somebody calculate and tell me what is the position of Q2? I pause.
You can actually construct it like if P,
Yes.
A and B are there.
Geometrically we can construct it, but present I want algebraic value of Q because I have got a number line there. So can we do? Can you use? Can
4.5.
Four.
how much?
4.5.
4
Nine.
point. Let us check. 4.5 he says. 4.5. So 9 by 2 is the position Q4. Let us check. PA upon AQ4 is equal to PA is 3 and AQ4 is 3 by 2. Correct? That is my K1, 2. K1 is equal to 2. And let us calculate PB upon BQ4. PB is 9 and BQ4 9 upon 9 by 2 बरोबर है into 2 upon 9 sorry 9 upon 2 which is equal to 2. Now we will give this as opposite sign. So K2 comes out to be minus 2. Is this position Q4 unique on this line? Yes. That is the unique position where both the ratios are same numerically, but the sign is different. So now if I add them Q1 plus Q2, it will become 0. And will we call this Q4 as harmonic conjugate? P comma Q4 are harmonic conjugates of A comma B? Yes. Therefore, Q4 is the required point as far as this problem is concerned. That is why the sum of the roots, that is sum of the k values, both the k values add up to 0, and hence this S12 is sum of the roots. It should be 0. Is it clear, Yukta?
Yes, sir. Thank you, sir.
Let us practice using t is equal to 0 and writing down the required equations very quickly. Not difficult, but sometimes you will have to. For example, find question 1. Find equation of tangent to ellipse. X square upon 25 plus y square upon 16 is equal to 1 at say I suppose if I put x is equal to 1, then what is y? Y is equal to 1 minus 1 upon 25 is 24 by 25 into 16, 24 into 16 by 25 root, which is 4 by 5 or 8 by 5 root 3 at 1 comma
6, sir.
root 6 root 6. Write down equation of tangent. Two x plus 5 root 6 y minus 50 is equal to. Now you do not know how this ellipse is, but you can find out the equation of tangent. Good. Question 2. find the equation of chord of contact of 2x square plus y square plus 5xy minus 3x minus 7y plus 14 is equal to 0 at from chord of contact of this end is of point -1, 3. आता मी काय पण करू शकतो. आता फक्त unfortunately let that point does not belong to this curve, but chances are very less. The equation of chord of contact is सांगा. अरे सांगा
4x minus 3y plus 5 is equal to 0.
See, you do not know what this curve is. No knowledge at all. Yesterday only you came to know what is chord of contact. And but still you are able to find out equation with all theoretical background. I mean, you are not just, I have not given you that formula and you are doing the calculations. It is not say, I mean, you have understood everything behind it, why it is working, and it is so quick. Okay. Now maybe I will help you in finding this out little quicker than what you have done. Is deliberately this is odd number, this is odd number, this is odd number, this is odd number. Therefore, you can write this if you want to really, I mean, this is very simple calculation, but still if you want to save time and make less mistakes, you may write it as 4x square plus 2y square plus 10xy minus 6x minus 14y plus 28 is equal to 0. Then you have the equation -1, 3. You can put it here so that you save time. So minus 4x, correct, plus 6y plus 5 inside bracket minus x plus 3y minus 3 inside bracket x minus 1 minus 7 inside bracket y plus 3 plus 28 is equal to 0. That is easy. No denominator, no fraction. Now you have to collect the correct terms. Minus 5, minus 3, minus 8, minus 14, no, minus 12x. Okay. 12 minus 3 ने multiply केले plus 9y minus 15 is equal to 0. Are you getting this? मी आपलं वरल्या ह्याला मल्टिप्लाय करून दिले 6y 15y आणि 21 वजा 7 काय चाललंय बरोबर आहे 15 आणि 6 21 वजा 7
तर ते x into y1 plus ते h ची टर्म चुकीची लिहिली आहे तुम्ही.
होय
सर
X
3x
minus y.
पाहिजे.
x1 दिलं मी xy1 नाही. Wrong. And I am sure any of you must not have done this way. Therefore, I have to write it correctly. -1 into y minus y plus 3x. Okay, आता x जमवूया. 15 minus 4, 11 minus 3, 8x. 6 minus 5 is 1y minus 7 minus 6y. बरोबर आहे प्लस कॉन्स्टंट टर्म इथे 9 minus 3 आणि 7 7 21 22, 23, 24, 28 वजा 9, 10, 31. थोडं माझा स्पीड कमी झालाय. 4x minus 3y plus 5 is equal to 0. No, what I am trying to tell you is, if you have many odd numbers, you multiply by 2 and then use the equation quickly. That should save your time. But if you are happy with half, no, I don't have any problem. So, let me give you one more. Question 3. Find the locus of harmonic conjugate of P 2 comma minus 3 with respect to curve. No, there are 2 comma minus 3 with respect to curve xy is equal to minus 6 with respect to point of intersection. I mean, you understand what I am trying to say. I should give you P and I should give you curve. Get me the locus of harmonic conjugate. चला बघा कामाला. Okay. 3x but this is harmonic conjugate, but actually it is tangent. Actually it is tangent because the point belongs to the curve. So tangent is a locus. We can, I mean, it is everywhere, everything is going to be 0 there. P is on the curve, A and B and Q and P, all 4 of them are coincident. That is the special case, and therefore it's a locus of harmonic conjugate. It's a polar. So I hope you have understood. 2xy is equal to minus 12 makes it x1, that is 2, minus 3 xx1, no, xy1 चुकतंय माझं. That implies xy1, so minus 3x plus 2y is equal to minus 12. That is what this equation is. This is rectangular hyperbola. You don't know anything about this curve, but you could find out equation of tangent, right? That is the advantage of learning bigger picture. Okay, let me pause. Okay, let us go back and start discussing circle again. I think the percentage is very less, 58. Let us write the standard circle. X square plus y square is equal to a square. Is a circle. S is equal to x square plus y square minus a square is equal to 0. That is circle, and line L is y is equal to mx plus c. L is tangent to S. If and only if what? Find coordinates of point of contact. Let me show you how to do it. There are three ways of doing this. Especially in case of circle, we have three ways of doing this. Let us do it by all three ways. Ninth standard method, solve L with S, make delta 0, quadratic equation. So x square plus mx plus c bracket square minus a square is equal to 0. This is quadratic in x, and if we want coincident roots, that line should be tangent, then delta should be 0. So let me first write down quadratic in x. 1 plus m square plus 2mxc plus c square minus a square is equal to 0. This is quadratic in x. And discriminant of this, delta should be equal to 0, is implies 4m square c square b square minus 4 1 plus m square, that is a, into c square minus a square, that is b. C should be equal to 0. Expanding, we get 4m square c square minus 4m square c square. Okay, पहली टर्म झाली minus 4c square plus 4a square. आणि अजून एक टर्म राहिली, 1 into this झालं, 1 into this झालं, 1 mn, आणि मग plus 4m square a square is equal to 0. This gets cancelled with this, and we have to report it in terms of c square. Therefore, c square is equal to a square inside bracket m square plus. This is the necessary and sufficient condition for y is equal to mx plus c to be tangent. Method number 1. Okay, so if this is method number 1, then we will get point of contact x coordinate by writing minus b plus minus whatever, and or maybe yes, we will get it that way, and we will get point. So we get first condition for tangency, and then if we process this, if we substitute this c square here by this, and then find the roots of this quadratic equation, they will be coincident, and we will get x value, x coordinate, and corresponding y coordinate we can find out. So we will get point of contact later. First condition for tangency, second point of contact. Okay, what could be the second method of doing it? Distance. It is a circle with center origin, center 0, 0, radius a. So y is equal to mx plus c should have a distance from m into 0 minus 0 plus c absolute value upon m square plus 1. Squaring both sides, we get c square is equal to a square into m square plus 1. Oh, this is very fast. But it is special case because it was a circle. Very, very fast. I don't know how you have done, and this is the fastest. Condition for tangency should be c square is equal to a square into m square plus 1, cross multiplying. इथे radical पाहिजे. Case number 3. Now whatever we have studied just now, recently what we have studied is tangent T is going to look like xx1 plus yy1 minus a square is equal to 0, where x1 comma y1 is point of contact. Correct? But we have been given mx plus y minus y plus c is equal to 0. That is the equation we have been given. So these two equations are not same, but their coefficients must be proportional because it is the same line represented in two different ways. This implies x1 upon m is equal to y1 upon minus 1 is equal to minus a square upon c. That implies y1 is equal to a square by c and x1 is equal to minus a square m by c. Oh, we got the point of contact first. Okay, and if this is the point of contact, then how do you get condition for tangency? Put that point in the equation of line. So x नाही काय करायचं? Who are they related to each other? They satisfy, this is the point on the circle, therefore minus a square m by c bracket square, that is x square, plus a square by c, that is y square, minus square is equal to 0. This implies जास्ती झालेलं आहे, ए खूप झालेत ना, ते काढून टाकूया. ए स्क्वेअर कॉमन काढला आणि तो डिवाइड केला, संपला विषय, तो गेला कामातून. Therefore what we get here is, let me write down, a fourth m square upon c square plus a fourth upon c a fourth upon c square minus a square is equal to 0. So multiplying everything by c square and dividing by a square, we get m square a square plus a square is equal to c square. That is the condition for tangency. So in the method number 3, where you are comparing coefficients, you get point of contact first. Okay, now I have explained you 3 cases, 3 methods, out of which this will work for any conics, any, only for circle. This is also any. So for remaining conics, whenever I tell you find the condition for tangency, you should work with either of these two or maybe both of them, because one gives you condition for tangency first and second gives you point of contact first. So with both of them you can find out. समजलंय का रे सगळ्यांना? Okay, so if the circle is S is equal to x square plus y square is equal to a square and P is x1 y1, quadratic equation in M, which is slope. Find the quadratic equation in M, slope, which is slope of tangent passing through P, tangent. Now, do you understand the question? Maybe you can write this minus. Question is, which quadratic equation will you solve? If you solve, you get two values of slopes. Those are the slopes of the tangent. We call that equation as auxiliary equation. Auxiliary equation. AUXILI. Auxiliary equation. Which auxiliary equation will you solve to get the slopes of tangents? This is easy circle with center at origin, but find out that auxiliary equation of quadratic equation in slope m. We have already found out the condition for tangency. C square is equal to a square into m square plus 1, and y is equal to mx plus c was our line. Therefore, c is equal to, and the point, I mean the line should pass through this point, therefore c is equal to y1 minus mx1. Correct? You put it over here. So y1 minus mx1 bracket square minus a square m square minus a square is equal to 0, and we want quadratic in m square inside bracket. Coefficient of this m square is x1 square minus a square, that is this, plus or minus, what is the coefficient of m? M will be 2x1 y1, so 2m x1 y1, and then the constant term that will be y1 square is positive minus a square is negative, which is equal to 0. So this is the auxiliary equation for finding out slope of tangent. Clear? Now, if we have this equation, then what is the locus? Next question I can ask immediately is, what is locus of point of intersection of perpendicular tangents? No, बरोबर. How? What is the locus of point of intersection of perpendicular tangents? I have been given a circle, x square plus y square is equal to a square, and if I want two tangents to be perpendicular to each other, I mean, school method is this, root 2 times radius. Yes or no? That is our school method. Locus will be, we can find out. But college method is use this equation. If the tangents are supposed to be perpendicular, their product of the slopes should be minus 1. What is product of the slopes here? m1, m2 is equal to minus 1. Product of the slopes is y1 square minus a square upon x1 square minus a square. Go to minus 1. Right? So y1 square minus a square plus x1 square minus a square is equal to 0. That is x1 square plus y1 square is equal to 2a square, replacing x1 by x and y1 by y. By y, we get desired locus x square plus y square is equal to 2a square. That is the advantage of looking at bigger picture. This is called director circle. Right, perpendicular tangent, locus of perpendicular tangents is a director circle. Okay, good enough. I think we should stop at this point because too many algebraic things we have done today. Let me stop recording.